Hi, hello, dear students. Welcome to my next session on this JEE mains chemistry related integer type questions and MCQ questions asked in 2024 April 4th afternoon session. We will see in this video 3 questions again like the previous videos, 2 questions integer type questions and 1 question MCQ question. In this, the integer type question is almost related to organic and mole concept, organic equation based mole concept question. The other one is thermodynamics work done related one. And the MCQ we are going to see that is from the coordination compounds chapter. Okay. Now, we'll see the first question. What is the maximum amount of acetonylide formed when acetic anhydride in excess is treated with 18 grams of aniline? Nearest integer, you tell the answer. That's what they have given. So now we will understand one point here. The reaction is taking place between aniline and acetic anhydride, leading to the formation of acetonylide. First we will understand that equation. What is aniline formula? Is C6H5NH2. And this aniline is treated with acetic anhydride. Acetic anhydride is CH3CO COCH3. Okay. And this acetic anhydride, when treated with excess of acetic anhydride is treated with aniline, then we will get acetonylide. What is acetonylide means? You abstract acetic acid from it, you will get C6H5NH. This is CH3CO part will come onto this nitrogen. So this is COCH3. The rest byproduct is acetic acid CH3COH. Now, in this chemical equation, we can start finding the maximum amount of acetonylide can be obtained. So this is what we call it as acetonylide, and this is aniline, this is acetic anhydride. The point is nothing but they have given 18 grams of aniline. That means here aniline 18 grams given. Aniline molar mass, if you calculate, it will come 93. So 18 by 93, 18 grams by 93 grams is the number of moles of aniline from the equation. The same number of moles of acetonylide also will be obtained. So that means as per the mole concept, number of moles of acetonylide, number of moles of aniline from this equation is same. That means 1 mole of acetonylide is coming from the equation. That means moles of aniline will be considered as the moles of acetonylide to find the mass of acetonylide. So how we will find the mass of acetonylide means number of moles into its molecular weight of acetonylide. Okay, then this will become the mass of acetonylide. So what is the mass of acetonylide obtained here is 18 by 93 into its molar mass will come 135. Calculate all the atomic weights and all, add, then 135 will come. So you'll write 135 it is. Okay, if you go with approximation calculation, if you take this is 90, this is 35, 135, 18 by 2 into 3 will come. So it is 9 into 3 is going to come, we will get 27 approximately, but it is more than 90 is there, so we will consider 26 approximately as the final answer for this question. As 93 is taken here, we have considered for 90 calculation. So 26 is the right answer for this maximum amount of acetonylide formed in this reaction. That is the integer type of question which they have asked in this exam. Hope you understand this mole concept related question, integer type of question. Take a snapshot of it and move to the next one. So we will see the second question. What is the second question is, in the second question, they are asking us to calculate magnitude of heat in an isothermal reversible expansion against external pressure 8 bar if volume increased by 10 liters. We all know that what is work done formula. Work done formula is equals to minus P external into V final minus V initial. So pressure given in the question already it is there, 8 bars is there, minus 8 into volume increased, initial is not given, so initial is 0, final is 10, so we will take 10 liter bars is there, liter bars or liter atmospheres. This is approximately taken as, you have to give the answer in joules they are asking. So this is minus 80 already there. Liter bar atmosphere bar can be approximately equals to 100 joules. Okay. So 100 into 80 is minus 8000 joules will come. That is the work done. But when we are finding the heat, then heat formula in the irreversible expansion is nothing but minus W formula. Minus W. So that means that is equals to 8000 joules plus 8000 joules will come. That is the answer for this magnitude of heat that is required for this kind of expansion. This is the second question which they have asked interestingly from thermodynamics of class 11. Okay, hope you understand this one. Next, moving on to that next question, that is coordination compounds. Coordination compounds. The question is, find out number of unpaired electrons in D subshell for cobalt complex, like COH2O 6 times 3 plus given. There are 4 options, 3, 4, 0, 2 options given to us. First of all, we should know what is the complex correctly given the formula we have to take down. That is COH2O 6 times 3 plus is there. And cobalt in its ground state configuration, we know that cobalt Z value is 27, that we have to consider. That is 3d7 4s2, 3d7 d7 4s2 and 4p0 also we can take if needed. Now what is the requirement we have is to convert this cobalt into plus 3, as in this complex cobalt oxidation is plus 3, so 27 minus 3 is just for 24 electrons we have to write this configuration, then it will become 3d6 4s0 4p0. In formation of this octahedral complex, it will utilizes the d orbitals, s orbitals and p orbitals. D to sp3 hybridization is going to come. And in this one, if we have d6 configuration is there, d6 configuration, the d6 configuration will be actually written like this, 6 electrons. Whereas in the presence of this ligand is there, these electrons will get rearranged. The electrons will get rearranged like this. That means the two splitting into two groups. One group we will call it as EG. The other group we will call it as T2G. This is EG group in octahedral complexes. All these 6 will arrange in the T2G only, as we know it is a ligand's behavior on the electrons. Then what will happen, these 2 electrons will be utilized for hybridization. So what is the ligand here we have is H2O ligands are there. When the ligand is approaching the central metal in between the axis, then automatically what will happen, so T2G orbitals will get the repulsion. That means the rearrangement will be taking place. These electrons will try to rearrange in the inner orbitals. So that rearrangement is now shown in T2G. Now EG has 0, T2G has 6. So once we write like this, what is the number of unpaired electrons in D subshell? This is D subshell only. D subshell we have mentioned in D subshell is nothing, 0. That means number of unpaired electrons is 0 in this D subshell of cobalt complex. So this third one is the right option for this question. So that's it. This is what we have discussed in this video for 3 questions, important questions which are already given in this year. So it may be given for the coming examinations also, CET exam or any kind of NEET examinations or CUET examinations. Any kind of competitive exam you are writing, these concepts and these type of questions are important for those exams. Those who have already wrote this exam, you can also check with your answers with these explanations. Thank you very much. We'll meet in the next section with another important the JEE examination answering in the April session of 2024. Thank you.